Hello everyone, welcome to this new analysis. Today we're tackling a big topic. We're going to demystify the famous large language models, or LLMs for those in the know. Honestly, this is an absolutely essential topic right now if you want to understand how artificial intelligence is literally reshaping the world of work and education. So shall we get started? Here's what we're going to cover together today. First, we'll understand what these LLM models really are, analyze how their prediction logic works, and then do a quick comparison of the major models. Next, we'll look at practical use cases, explain why AI tends to hallucinate, and finish with how to verify and validate information. Alright, let's dive right into our first section, understanding LLM models. What exactly is hidden behind this acronym? Basically, an LLM, which stands for Large Language Model, is an extremely sophisticated artificial intelligence program. Imagine a system that has been trained on billions and billions of texts, books, websites, and forums. It's all this background that makes it capable of holding ultra-smooth conversations and generating ideas in a truly astonishing way. But be careful, keep this in mind, the machine has absolutely no real thoughts. It only processes raw information. Let's break down these three letters, LLM. The first L stands for large, which simply means big, because we're dealing with a system that contains billions of parameters. That's what allows it to grasp ultra-complex structures. Next, the second L stands for language, which means it uses our syntax and human logic to understand our requests. And finally, the M stands for model, which is actually a network of artificial neurons that learns by spotting patterns with the sole purpose of making predictions, which logically brings us to our second section, the logic of prediction. How does it really work under the hood? And here I love the analogy shown in this image, the famous probabilistic chick. It's a perfect metaphor to remind us that these AIs don't think in a logical or conscious way at all. In reality, they simply predict statistically which word is most likely to come right after the previous one. It's a bit like a highly evolved parrot that relies solely on the gigantic mountain of text it read during its training. To make this clearer, take a look at these numbers. If you type the beginning of the sentence, the chick, the model will calculate probability percentages for the next word. It will think, okay, there's a 90% chance that it's is, 70% that it's eats, and let's say 20% that it's the adjective yellow. There you have it. It's thanks to this simple little probabilistic exercise that AI manages to generate entire paragraphs that are perfectly coherent syntactically. Let's move on to our third part, the comparison of major models. How can we evaluate these famous tech giants? Here, we rely on the very detailed chart by expert David Fayon. He compared 6 major names in the market in a completely impartial way. Of course, it includes ChatGPT from OpenAI, Gemini from Google, the excellent French alternative Mistral, as well as Perplexity, Claude, and the Chinese tool DeepSeek. To distinguish between them, he looked at extremely precise criteria: the frequency of their hallucinations, the freshness of their data, their biases, and even their ability to create images. What you should take away from this is that there isn't a perfect model, but rather a tool with very specific strengths depending on your needs. By the way, the big winner of this comparison is quite unexpected. Overall, ChatGPT takes first place, yes, but by a very narrow margin and almost solely because it outperforms the others in image generation. Because, and this is truly fascinating, if we remove this purely creative criterion, well, it's Perplexity that takes the crown, followed by Claude. This is a crucial nuance to keep in mind when choosing your everyday work tool. We're now at our fourth section, practical use cases. How can we apply all this in the real world? Today we should no longer see these models as mere gadgets, but as true virtual collaborators. Their real strength isn't to replace us, but to amplify what we already do. By delegating heavy and repetitive administrative tasks to the machine, we free up valuable time that we can finally devote to what we do best: strategy, reflection, and creativity. So, concretely, what can we do with it? The possibilities are enormous. You can ask it to write a text or generate a marketing strategy in just a few seconds. For developers, tools like Copilot act as real assistants for live coding. In finance or law, it can be used to instantly summarize an ultra-complex document. And of course, you can conceptualize and create high-quality images with just a brief description. The impact is being felt absolutely everywhere. But be careful, it's not all sunshine and roses. This brings us to Section 5. Why does AI hallucinate? The famous trap of predictive models. This is a question we absolutely have to ask ourselves. How can such a powerful system, trained on almost all of human knowledge, still manage to produce completely incorrect information? The culprit is what we call hallucination. A hallucination is when the AI gives you an answer that is factually incorrect, but it wraps it up with so much confidence and such perfectly structured sentences that it seems completely true. Why does it do that? Well, remember the chick, it's a probabilistic model. Sometimes it miscalculates its statistics or relies on imperfect training data, and bam, it makes things up. Look at this great example shared by the Machine Learning Lab. If you ask an AI who wrote Les Miserables in 1920, the machine will get confused about the year. This strong statistical probability associated with 1920s literature will lead it to confidently claim that the author is Marcel Proust. It completely overlooks Victor Hugo. Once again, it doesn't think about the meaning, it just mathematically associates words. That's why we need to move on to our final step, section 6, checking and validating the information. This is crucial for mastering the tool safely. And believe it or not, safety starts with the very first word you type, your famous prompt. It's up to you to guide the machine. The more precise context, details, and clear examples you give it, the less room you leave for it to go off track and make up facts from scratch. So, to help you out, here's a simple 3-step workflow that's super easy to remember. Step 1, provide a very precise context right from the start. Step 2, get into the habit of requiring the AI to explicitly cite its sources. And step 3, to check and validate facts, prioritize tools that are directly connected to the web in real time, like Perplexity or Gemini extensions. This allows you to cross-check information immediately. Which brings us to the main lesson in all of this. It always comes back to the human. It's our critical thinking that matters most. No matter what, any information produced by an AI must be reread, analyzed, and evaluated by you. These algorithms are incredible accelerators, that's clear, but they will never replace the perspective, expertise, and common sense of a human brain. To conclude this analysis, I'd like to leave you with this thought. As these predictive AIs are becoming our everyday co-pilots, how will our own human critical thinking need to evolve so that we don't fall for the illusion of the machine and always stay one step ahead? That's quite a challenge ahead of us, don't you think? Thank you very much for following this explanation with me, and see you soon.